Okay, let's measure the temperature of the room using a Raspberry Pi Pico, and this is a good thing to do because you don't have to connect any sensors. You can just do it with the basic Raspberry Pi Pico. You don't even need a breadboard. You do need the Thonny app or another IDE, Integrated Development Environment, the app you use to code with Python. So once you've installed Thonny, which is free and has no adware or anything, you can then select the MicroPython option. If you don't see this option here, try a different USB connection, try a different USB cable. Some micro USB cables are for power only and some are for power and data. We need the power and data one, obviously. And you also need to install MicroPython, and if you haven't done that yet, see the previous guide. Right, let's look at some code. Okay, so this is the simplest, most basic code snippet I could come up with that gives us a result, and we'll build on this in a minute, but first of all let's understand it. So line 1 and line 2, you're importing libraries. Import time just means that we can make the program pause for a second. This first line is importing ADC, that stands for analog to digital converter. The temperature sensor is a analog sensor, so we just need a way to convert that value into digital. So we've got a variable here, and that is linked to the sensor that is built into the Pico. The reason we're doing this is it's a really simple project that doesn't require any other hardware or connecting things to the Pico. It's all built in, and it's linked into channel 4. You can't see this, it's not an external pin, but it is the 4th channel built into the internal structure of the Pico. And we've got a while loop, so it's going to loop everything that's indented. Every second it will do this while loop, and on each loop it will store a value into this new variable, which is sensing the current temperature from that ADC sensor that we linked to up here, and then it will print that out so that we can see what we're doing. Now it's a 16-bit number, binary number, 16-bit binary number, which is, it's quite interesting. So let's have a quick look. The values that we're going to see in a second can range between 0 and 65535, and that's because each time a sensor reading is taken, it's using 16 bits. So, and each one of those bits can be a 1 or a 0. It's a binary number, 16 bits long, and that can give us a maximum value in denary of 65,535. So what does that actually mean when we run this program? You can see it is outputting a denary value. Clearly this isn't centigrade or Fahrenheit, it's raw data, so we'll talk more about that later. And every second it is printing this variable based on the 16-bit binary number we mentioned earlier. So these values here could range from 0 and about 65,000. And if you put your hand over the sensor, you should see some changes in the value being output, and you might see a bit more clearly if we go to View at the top of Thonny and turn on Plotter. You can see on this line graph that if I put my hand on top of the sensor, you can see that the values are in fact going down and not up. So why are these readings going down and not up? Surely if the sensor is getting hotter, the values would be going up. And this is all to do with how the Pico is actually working out what the temperature is, and it's not actually got a temperature sensor in there. It is reading tiny fluctuations in the voltage that change on a very small scale, depending on the temperature, and it can sense those changes and then work out what the temperature is based on a sort of built-in algorithm. Now let's work out how we convert this raw value to something more useful to us, such as degrees C. Okay, so this code has been updated now and hopefully will output the temperature in degrees C, and much of it is the same as you've seen before. So we've got the two libraries, we've got the temperature sensor that is linked to the hardware, and we've got this variable in a while loop, ADC value, which is reading that 16-bit value that could between number between 0 and 65,000. So that is as it was before. Okay, these comments here don't affect the code at all, they're just for information. So if you're copying this code out, you don't actually need this grey stuff. Okay, so there's some other stuff now in this while loop that's new. So we've got a voltage variable, okay, and that is going to convert the ADC value, and it takes the expected voltage 3.3 volts and converts it into a voltage value. And maybe we should actually have a look at that and see what the output is. So if we print that variable and then we run this program, you should be able to see two sets of numbers on each while loop now. So you can see that it is outputting this number, the 0.7, that's the voltage value, and the one with degrees C at the end is the actual temperature in degrees C. And if I put my hand over it, you should be able to see that the degrees C is going up, okay? But look at the voltage. Can you see the voltage is going down slightly? So this is what I was saying earlier, is how this senses temperature. It takes fluctuations in voltage and converts them to degrees C. And we don't really need to see the voltage, so I'm going to take that out again. So we've got a variable for voltage, and then the temperature in degrees C is going to be this formula here. Okay, so you don't have to know in too much detail about that, but this is basically going to output a number that is degrees C, and line 10 does that. It takes the variable and then it just adds some string text on the end, so it's labeled for us humans to see. And if we run this, you can see now it's saying 20.95, 20.49. If I put my hand over the sensor again, hopefully you will see that it's getting warmer, 21 degrees now, 22 degrees. So that is actually doing what we would expect it to do. The number is going higher as we warm up the sensor. Okay, do you think you can try and get that working? Once you have got that working, we can move on to the next thing, maybe reducing the number of decimal places, because it's just confusing to have this many. And then the next thing after that is we could make things like the onboard green LED light up if the temperature goes above a certain value. Okay, so this is the code outputting lots of decimal places for each degrees C reading. So how can we reduce the number of decimal places? Perhaps the easiest way to do it is to just round down the number of decimal places, and you can do that very easily. We've got a value here, temperature. So if we just create a new variable called temp rounded, and let's just reduce that, and then you can use, we're going to assign a value to that, which is rounding the temperature, and let's reduce it to 1 decimal place. Okay, so the temperature is rounded down and it's saved assigned to this variable. So instead of printing the temp variable, we want to output the rounded temperature variable. And now you can see that that has been reduced in the number of decimal places. So what else can we do? Well, what are we going to do with this data? One of the reasons we chose to do this project is it doesn't need us to plug anything in, but as you get more into your Raspberry Pico adventures, you want to do things with these readings, and later on you might want to do things with sound sensing or temperature sensing or movement sensing. So this is a good opportunity for us to take this data and do something with it. So hopefully you remember this video, the previous video, 1.1 getting set up, in which we learned how to make the onboard green LED light on and off. And we can use that code now to respond to the temperature settings that are outputting from our current program. Okay, I've made some additions to our code. So I've added a new library. Remember, this was what we did when we made the onboard green LED light up in our previous tutorial. So we need to import the pin library, and we have a variable that links this variable, this name, to the hardware, as we did with the temperature sensor. Okay, don't forget to capital P. This has to be 25 for it to link to the right hardware. Okay, so now we can use that variable in our while loop. So every second we've got a temperature reading, okay? And what we have done is in here we have added an if statement. So be careful with your indentation, but basically every second it will read what the current value is that has been assigned to this variable, and if it is greater than or equal to 16, we're going to make the green LED light up. If it's less than 16, the green LED will be off. So if we now hold our sensor with our hand to see if we can make it light up, you can see that it has indeed made the green LED light up. And if we allow the temperature to drop below 16 degrees, the green LED switches off. Okay, so we're about done with this tutorial. I hope you found it useful. I think it's a great one to do because it doesn't involve too many other things connecting, and whenever you do connect other things can go wrong. So this was a great opportunity for you to use a sensor that was built in and then do something with that. So it was in a while loop, repeating it every second, and then depending on the output you could make different things happen using an if statement. The next step would be to maybe make a LED strip light up depending on the temperature, or you could make individual pixels light up in like a temperature gradient depending on the temperature, or make different colored LEDs appear depending on the gradient. So it's a really good progression to more complicated things. Good luck!